So in this video we are going to learn how to calculate equilibrium constant by using initial change equilibrium table. Without any further ado, let's move to an example. Calculate the equilibrium constant for the given reaction if you place 8 moles of nitrogen dioxide in 2-liter container at constant temperature. After the equilibrium was reached, the number of moles of nitrogen dioxide was 4 moles. So we have 8 moles first in the container, which means there are the initial number of moles, and 4 moles that remain in the container after the reaction takes place, which means that are the number of moles at the equilibrium. So first we are going to calculate the initial concentration for nitrogen dioxide and equilibrium concentration for nitrogen dioxide by using the volume of the container given here and the number of moles. So at this step we found the initial concentration for nitrogen dioxide and the equilibrium concentration for the nitrogen dioxide. Now let's write the equilibrium constant by using the balanced equation. Be careful at this step because if you have solids or liquids, they are not included in the equilibrium constant. All these concentrations here are equilibrium concentrations that we are going to find. We have only the equilibrium concentration for the nitrogen dioxide and the initial concentration for it. In order to do this, we have to draw a table that is called initial change equilibrium table. Let's draw it. So now in this table we are going to place the values that we have. We have 4 molar for the initial concentration for nitrogen dioxide and 2 molar for the equilibrium concentration for nitrogen dioxide. We do not have any nitrogen oxide at the beginning without starting the reaction, and also we do not have any oxygen. Now for finding the other values, first we have to know that initial plus change is going to give us the equilibrium concentration. From this we can find the change. So initial plus change is going to give equilibrium concentration. So the change is going to be equilibrium minus initial concentration. So it's going to be 2 molar that is in equilibrium minus 4 molar that is the initial is going to be minus 2 molar. The change is going to be minus 2 molar. And it makes sense because you have only the reactant and the equilibrium goes to the right, to our products. Now, in order to find the other changes, you have to look at the balanced chemical equation. At the first one you have a 2 coefficient, the other one for the nitrogen oxide is 2 and for oxygen is 1. So the change for nitrogen dioxide, we found it from these formulas here. Now in order to find the change for the nitrogen oxide, we have to look at these coefficients here. We see that they are equal with the nitrogen dioxide, which means that the change here is 2 molar, the same. But in the case of oxygen is 1 compared to 2, which means it's half the concentration of the nitrogen dioxide, 1 molar, plus plus, because we have formation of the products. Equilibrium is going to be 2 molar and 1 molar, because if we sum initial here we do not have anything, it's only the change. This is going to serve as equilibrium concentration in this case. From these equilibrium concentrations, we are going to find the equilibrium constant. So the equilibrium constant is equal, again, let's place the values. So the equilibrium constant is 1. Thanks for watching guys, see you in the next video. Peace!